2.1, here's the bell problem. Identify the domain and the range. Don't forget to write a capital D for domain followed by a colon and then a squiggly. End it with a squiggly, and the same thing with the range. For the domain, you should get -3, 0, 2, 9, and 23. And for your range, we should get -99, -18, 0, 7, and 14. Yesterday we talked about relations. Today we're going to figure out if those relations are actually functions. And we can do this because you already have this definition written down. It's a relation for which each input has exactly one output. So if any input of a relation has more than one output, the relation is not a function. So if we look down here, we have the relation from A to B. Notice how 1, our input, has 2 arrows going away from it. Since the input has more than one output, this would not be considered a function. So, we have a couple examples. We have 3. Looking at the first one, we have our domain, we have our range. We look at our domain, we look to see if there's only one arrow going from every number, and there is. So yes, it would be a function. Then we look at B. Look to see if any of our x values repeat. So we have 4, 8, 1, 6, and 4. Noticing how the first x value and the last x value are the same, and they both go to different numbers, so no, B would not be a function. And then looking at the last one, you determine if this domain to range relation is a function or not. And if you notice, 2 has 2 arrows going from it to 2 different numbers, -3 and 3, so no, this last example would not be a function. We can also test to see if they are functions by doing a vertical line test. A relation is a function if and only if no vertical line intersects the graph at the relation at more than one point. So again, a vertical line is like this red line here. You can draw this vertical line through any part of our function, and the blue part is our function. It's in the shape of a U, which is a parabola, which we eventually learn. And anywhere where we draw this vertical line, it will only hit the graph once, so yes, it is a function. If you look over here, we have a sideways U, and if we draw our vertical line, we will get 2 points of intersection at the top and at the bottom here. Since there are 2 points of intersection, this will not be a function. So use the vertical line test and determine which graphs, if any, represent functions. You should know that A hits it twice, so that is no. B only hits it once wherever we go. Notice in the shape of a V, so this is an absolute value. We talked about solving absolute values, but we have not talked about what they look like. That will come eventually. But B is, yes, it is a function. And C, notice how we don't have any straight lines or curved lines connected, but we have dots. And notice how there are 2 dots on the same line, so this makes it not a function. So these are like graphing our ordered pairs. Notice how they would have the same x value, but different y values. Next, for f of x equals -2x plus 5, what is the output values for these following input values? All we have to do, my suggestion would be, wherever you see an x, replace it with parentheses. So we have f, I see an x, so leave that parenthesis blank, equals, we have -2, I see an x, replace it with parentheses, and then we have plus 5. We do each of these at separate times, so I'm going to start with -3, and we'll put -3 in our parentheses. When we're evaluating to find the input, since we replaced x with -3, we don't do anything on the left-hand side, we just evaluate over here. So negative 2 times negative 3 is 6, plus 5, and we get 11. And then you do the same thing for 0 and 1/4. Come back with your answers. So when we replace x with 0, f of 0, we get 5. And when we replace f with 1/4, f of 1/4 is 9/2. So go ahead and do the same thing for a, b, and c. Again, all you have to do is replace your x value with parentheses and plug in the input value to get the output value. For a, you should get 9. For b, you should get 1. And for c, you should get negative 19. Next, those lovely word problems that we all enjoy. Tickets to a concert are available online for $35 each, plus a handling fee of $2.50. The total cost is a function of the number of tickets bought. Write a function and evaluate the function for 4 tickets. So again, we first have to write our function. Since we're talking about tickets bought, I'm going to use t as my variable, so my function is going to be f of t being my input, and f of t being my output. And I want to figure out the total cost. Since there is a handling fee of $2.50 for each ticket, that gets added on. But if you notice, each ticket is $35, so we have 35. And we don't know how many tickets we bought quite yet, so we'll put the T for tickets with the cost of the ticket, and the handling fee we add on to the end, $2.50. Now they tell us that we're going to buy 4 tickets, so this is easy to solve. Wherever we see a T, we replace it with 4 to figure out the total cost of our tickets. So when you plug in 4 for T, we get $142.50. Again, when we buy 4 tickets, it will cost us $142.50. This next example here, we're buying bottles of sports drink for a volleyball team. Each bottle costs $1.19. We have to write our function and evaluate. So it looks like we're going to have about 15 people on our volleyball team. We're still talking about a function. I'm going to use b for my variable since we're talking about bottles. And each of them just costs $1.19. And we don't know how many we bought quite yet. So we're going to take the cost, put our variable at the end, and this is our full equation. Then we have to evaluate for 15 bottles, so we plug in 15 wherever we see B, multiply by 119, and we get $17.85. Now that we have finished 2.1, you should be able to identify relations and functions, domain and range.